What if I told you that we're already building a way to leave Earth not with rockets, but with a cable stretching over 35,000 kilometers into space? A structure so tall it would pierce the sky, reaching all the way to geostationary orbit. It's not science fiction anymore. Top scientists, engineers, and even space agencies are seriously considering it. A space elevator could revolutionize space travel forever: cheaper launches, zero emissions, even permanent space stations supplied like cities. But here's the terrifying part: what happens if it collapses? The cable alone, under tension, could slice through the Earth's surface. Climate change, resource scarcity, overpopulation, all pushing us to look up. But at what cost? What secrets and dangers lie in that cable to the stars? Hit like, subscribe, and let's go. For over a century, the dream of building a space elevator has lived in the minds of visionaries, from science fiction authors to real-world physicists. But today, that dream is quietly becoming a blueprint. In our modern world, where rockets still explode, fuel costs billions, and launches poison the atmosphere, the idea of reaching space without combustion is no longer just a fantasy, it's a necessity. Imagine a cable, thinner than a pencil, but stronger than steel, rising from an ocean platform near the equator and climbing straight into the sky, anchored to a massive counterweight in orbit. This elevator could transport cargo, satellites, even humans, smoothly, silently, into space at a fraction of the cost. We're talking about a future where supplies to Mars or the Moon could be lifted effortlessly, where orbital solar stations feed energy back to Earth, where leaving the planet is no longer reserved for billionaires and astronauts. But this vision, as magnificent as it sounds, comes with staggering technical, environmental, and existential challenges. Right now, the strongest material we know, carbon nanotubes, is just barely capable of supporting such a structure, and only in laboratory conditions. Political tensions, unstable weather systems, the sheer risk of catastrophic failure, these are no small obstacles. And yet, the pressure is rising. Climate collapse. We're over dwindling resources. The need to escape, to expand, to survive, is becoming louder with every passing year. So the question isn't just, can we build a space elevator? It's, should we? And what will happen to our planet, and to us, when that first cable finally touches the sky? The idea of a space elevator didn't come from an engineer, it came from a dreamer. In 1895, Russian scientist Konstantin Tsiolkovsky, inspired by the newly built Eiffel Tower, imagined a structure so tall it would reach geostationary orbit. No one took it seriously. Not then. Not when Arthur C. Clarke wrote about it in 1979. Not even when NASA explored it in classified reports. For decades, it was dismissed: too dangerous, too massive, too far-fetched. But something changed. In the early 2000s, breakthroughs in nanomaterials, especially carbon nanotubes, ignited a spark. Theoretical designs became technical papers. Universities began competing in climber challenges, tiny robot prototypes racing up tethers held by helicopters. Corporations started filing patents. And quietly, governments watched. Because this wasn't just a science project. It was the key to dominance in the new space economy. The country that builds the first working space elevator could control satellite deployment, space mining, orbital defense, even extraterrestrial migration. But here's the terrifying truth. The closer we get, the more we understand how fragile this dream is. The tension in the tether would be so extreme that even a small meteor strike or terrorist attack could snap it, unleashing a whip of energy powerful enough to flatten cities. Earthquakes, hurricanes, even solar flares, all become existential threats to a structure that never sleeps. And once it's operational, it can't be turned off. There is no emergency brake, just thousands of kilometers of cable, pulling down with relentless force. What began as a vision of peace, of progress, is now tangled in military interests, corporate secrecy, and geopolitical power plays. We're building a ladder to the stars, but every step upward might be one closer to the edge. To truly understand what's at stake, let's look at the numbers. A single space elevator would require a tether stretching over 35,786 kilometers. That's nearly 3 times the diameter of Earth. The cable must be strong enough to support its own weight under constant gravitational and centrifugal forces, and yet light enough not to collapse under tension. Today, no material on Earth meets that requirement on a practical, scalable level. Carbon nanotubes and graphene, while promising, remain unstable at industrial scale. And here's where it gets dangerous. The moment such a structure is built, it becomes a permanent target. Imagine a 36,000-kilometer line, thinner than a finger, slicing through the atmosphere. If it snaps, it doesn't fall gently. It whips around the planet at hypersonic speed, capable of demolishing everything in its path. Skyscrapers, bridges, power grids, gone in an instant. If the base platform is located at sea, as most concepts suggest, the falling cable could ignite the ocean surface, tearing through shipping lanes and coastal cities. And that's only the physical threat. Now consider cybersecurity. Once operational, the elevator would depend entirely on automated systems, AI-controlled climbers, smart brakes, real-time satellite data. One hack, one corrupted signal, and an entire continent could be in danger. This isn't fiction. In 2023, Japan's Obayashi Corporation announced a roadmap to build a space elevator by 2050. They've already started experimental tests. The countdown has begun, and yet, public discussion is almost silent. No headlines, no debates, just quiet progress toward a project that could either save civilization or end it. This isn't the future of some distant galaxy. This is our planet, our skies, our lives. And we're building a structure that, once it stands, might never come down safely. Here's the twist almost no one talks about. Building a space elevator on Earth might be impossible. Not because of imagination, not even because of politics, but because of physics. The very rotation of our planet, the same force that allows the elevator to stay taut, balance between gravity and centrifugal pull, also makes it terrifyingly unstable. Any misalignment, any sway caused by winds, temperature shifts, or orbital debris, and the entire structure could start to oscillate. Scientists call this the pendulum death swing, a phenomenon where the tether, once disturbed, begins to swing wider and wider until it tears itself apart. No emergency system has ever been proposed to stop that motion. And here's the part that sends shivers down the spine. If such a collapse happened, it wouldn't just destroy the elevator. It could trigger seismic activity, atmospheric shockwaves, and firestorms across multiple regions. But wait, there's more. In recent years, a group of researchers has proposed building the first space elevator, not on Earth, but on the Moon or Mars. Why? Lower gravity, no atmosphere, no hurricanes, much safer. But this raises another question. If we perfect the technology off-planet first, who controls it when we bring it home? Corporations? Governments? Or a private alliance beyond public accountability? Some scientists argue that we may be creating the largest private weapon ever conceived, a structure that could dominate orbital space, control satellite access, or, in the wrong hands, hold the Earth itself hostage. What started as a pathway to the stars is now tangled in ethical dilemmas, geopolitical tension, and a race for power. And while we look up in awe, dreaming of progress, perhaps we failed to look down long enough to see what could unravel beneath us. Today, the dream of building a space elevator is closer to reality than ever before, thanks to cutting-edge research in materials science, robotics, and space exploration. Carbon nanotubes, once a mere theoretical idea, are now being produced in limited quantities, and researchers are working tirelessly to develop them at a scale large enough to support the weight of a massive space structure. But the challenge doesn't stop there. Even with the perfect material, the space elevator would need highly advanced robotics to transport goods and people. Current designs envision automated climbers capable of traveling along the tether, powered by solar energy. These climbers could revolutionize how we send materials into orbit, making space travel cleaner and more efficient than any rocket could. But perhaps the most astonishing development is in the field of artificial intelligence. AI could be the key to maintaining the space elevator's operation. With real-time data streaming from satellites, automated systems could adjust the elevator's tension, monitor for wear and tear, and even anticipate catastrophic events before they happen. But here's the unsettling truth. Technology advances faster than our ability to understand the consequences. Each new step toward constructing the space elevator brings with it potential risks that we've only begun to explore. For instance, the design of these elevators relies on highly sensitive, high-altitude sensors that can monitor structural integrity. But what happens when these sensors fail? or a hacker manages to disrupt the system. The ramifications are almost too terrifying to imagine. And while private corporations and space agencies like NASA are pouring billions into this research, a lack of global regulation or oversight could lead to catastrophic consequences. We are advancing towards space, but are we ready to face the dangers that come with it? As we stand on the precipice of this technological marvel, there are conflicting voices. On one side, scientists and engineers paint a picture of a future where space elevators are the gateway to a thriving off-world civilization. With the ability to launch cargo into space without relying on rockets, humanity could build massive space stations, mine asteroids, or even establish permanent colonies on the Moon and Mars. The benefits seem limitless: cheaper energy, access to new resources, and the possibility of transcending Earth's environmental limitations. But there's another, darker side to the story, a side that asks, what price are we willing to pay? While the benefits of a space elevator are clear, so too are the dangers. Critics argue that the sheer size and complexity of such a structure make it an irresistible target for sabotage. Even a small error, an unnoticed crack in the cable, could lead to catastrophic consequences. We're not just talking about a collapsed tower, but an unstoppable chain reaction that could devastate the entire planet. Imagine this: a single terrorist attack on the elevator's base or an act of war against the nation controlling the elevator could send the cable into free fall, slicing through the Earth, igniting the atmosphere, creating global tsunamis. Another theory is that such an ambitious project could trigger a shift in Earth's gravitational balance. If even a slight miscalculation occurs, the consequences could be more extreme than anyone anticipates: earthquakes, tidal waves, climate destabilization. The future we've dreamed of may turn into a nightmare we can't escape. The most unsettling theory, however, comes from within the scientific community itself. What if the space elevator was never meant to be built at all? Could it be that this push for progress is nothing more than a distraction, a dangerous gamble that has no way of paying off? As we race toward the stars, perhaps we're overlooking the darker forces pulling us back to Earth. As the space elevator project moves closer to reality, the practical implications are becoming clearer and far more disturbing. The promise of easier space access, resource extraction, and interplanetary travel is undeniably powerful. But at what cost? We've reached a point where the line between technological progress and existential risk has blurred beyond recognition. Imagine a world where the space elevator becomes operational, a monumental achievement in human engineering. Yet, as the first climbers ascend, it becomes apparent that the elevator's true cost is more than just physical. It's psychological, environmental, and political. Governments and corporations now hold unprecedented power, controlling not just the elevator, but everything it enables: space stations, communication networks, mining colonies, and even military advantage. As these entities consolidate power, the world below is left reeling. Resources are diverted, environmental concerns are ignored, and the socio-economic divide widens. A new class of space dwellers, free from Earth's burdens, begins to dominate. The people left behind on Earth, vulnerable, struggling, begin to question: who is in control? What happens when the very technology designed to help humanity instead splits it apart? The key moment comes when a single failure, a malfunction in the automated systems controlling the elevator, sends shockwaves across the globe. The tether snaps. A cascade of events follows: natural disasters, economic collapse, and political upheaval. Entire coastal regions are wiped out by the debris falling from the cable's broken remains. A once promising future for humanity becomes its greatest disaster. The planet is scarred, and the consequences of playing with forces beyond our understanding are now painfully clear. In the aftermath, society is forced to confront its own hubris. How far are we willing to go to reach the stars, if it means tearing our world apart? As we look back at the relentless march toward a space elevator, we are left with an undeniable truth: humanity stands at a crossroads. The question is not whether we can build this monumental structure, but should we? Progress has always come with a price. From the Industrial Revolution to the digital age, each leap forward has been accompanied by unforeseen consequences. The space elevator promises the ultimate victory over Earth's limits, the chance to unlock the vast potential of the universe. But with this technological marvel comes a terrifying cost: control, power, and the very stability of our planet. The core dilemma is clear: evolve and risk everything, or halt and preserve what we have. We've reached a point where the tools we've created to secure our future may very well be the instruments of our destruction. This is no longer just a scientific experiment, nor a race to the stars. It's a moral question. Do we gamble with the Earth's future to secure our place in space? Or do we acknowledge the risks, the possibility of global devastation, and choose to step back? History has shown that humanity often races ahead, driven by ambition, only to be caught in the consequences of its unchecked desires. And in this case, the stakes are higher than ever. The space elevator, a dream for some, a nightmare for others, will ultimately test humanity's resolve. Are we ready to wield the power we've unlocked? Can we learn from our past mistakes? Or will we blindly push forward, blind to the forces we are tampering with? The choice is ours, and the answer may define whether we rise to the stars or fall to the earth below. Imagine standing on the edge of the earth, looking up at the towering cable stretching from the surface to the stars. You feel the weight of the world beneath your feet, but you also feel something else, the pull of the unknown. This isn't just a story or a fantasy. It's a reality we are speeding toward, whether we're ready or not. What happens when we reach for the stars and the very ground beneath us trembles? When the dreams of the future carry the risk of destroying everything we've built? It's a question we all must face. And deep down, I can't help but wonder, what if we're too late to turn back? What if the race to colonize space has already cost us our humanity? These are not just hypothetical dangers. They are real, and they are coming. And I have to ask you, are we willing to make this sacrifice? Is the desire to leave Earth, to escape our own flaws, worth the potential to lose everything we've ever known? I know it's hard to see the full picture. We want to believe that technology will solve our problems, that it will lead us to a brighter future. But have we truly stopped to consider what it might cost? As we hurtle forward, blinded by progress, we must ask ourselves, what price are we willing to pay? So, I leave this with you. If you were given the choice, would you still climb? Or would you stop before the tether breaks? Let me know your thoughts in the comments below. Because this story isn't just mine. It's ours. It's your future. And it might already be too late.